This lesson is about the derivative of the exponential functions. At the end of this lesson, you must be able to differentiate exponential functions and simplify the derivative expression using the laws of exponents. Again, let us recall from algebra how an exponential function is defined. The exponential function with a base a positive number and not equal to 1, is defined by the function y is equal to a to the x, where x is a real number. Since the exponential function is the inverse of the logarithmic function, then y equal to a to the x may also be written as x is equal to log of y to the base a. Recall that we have these laws of exponents from algebra. First is we have the product of two powers, a to the m times a to the n, to equal a to the m plus n. The ratio of a to the m to a to the n may equal a to the m minus n whenever m is greater than n, or is equal to 1 when m is equal to n, or equal to 1 over a to the m minus n when m is less than n. The n power of a to the m is said to equal a to the m times n. The product ab raised to the n is equal to the product of a to the n with b to the n. And when you have the ratio a divided by b raised to n, this is equal to the ratio of a to the n to b to the n. A to the 0 is 1, provided a is not 0, and that a raised to m divided by n is equal to a to the m, the quantity raised to 1 over n, or it is equal to a raised to 1 over n, the quantity raised to the m. A log of x to the base a is said to equal x. And if a to the m is equal to a to the n, then m is equal to n. When operating with exponential functions, then these rules would also apply. In differentiating exponential functions, we have the following rule. The derivative of the exponential function for any given base and any differentiable function of u are given as follows. For any given base a, the derivative with respect to x of a to the u is equal to a to the u times ln of a times du dx, where u is a function of x. And for any given base e, the derivative with respect to x of e to the u is equal to e to the u times du dx. Again, u is a function of x. To illustrate how to make use of these differentiation rules, let us work on some examples. For number 1, we have function y defined equal to e to the 4x cubed. Y prime then would be the derivative with respect to x of e to the 4x cubed. Please take note that the given function is just of the form e to the u, and that the derivative of e to the u with respect to x is given by e to the u times du dx. Hence, y prime here would just be given by e to the 4x cubed times the derivative of 4x cubed given by 12x squared. Or we may write y prime equal to 12x squared times e to the 4x cubed. Another example is defining f of x equal to 5x squared times e to the x cubed. What we have here for the function f of x is a product of 5x squared and e to the x cubed. So that to differentiate the function, we will be applying the product rule for differentiation, that the derivative with respect to x of the product f times g would equal f times the derivative of g with respect to x plus g times the derivative of f with respect to x. Applying that here, f prime of x will now be defined equal to the constant 5 times the derivative of the product x squared times e to the x cubed given by x squared times the derivative of e to the x cubed with respect to x plus e to the x cubed times the derivative of x squared with respect to x. Differentiating now the factors as indicated, then f prime of x would be equal to 5 times x squared times the derivative of e to the x cubed given by e to the x cubed times the derivative of x cubed, which is just 3x squared, plus the product of e to the x cubed with the derivative of x squared given by 2x. We now simplify the form of f prime of x. Take note that among these terms, e to the x cubed and one factor of x now would be common factors. So if these are factored out, grouping it with 5, then we have this expression here equal to 5 times the common factor x e to the x cubed times what is left of this sum when we factored out x e to the x cubed, and that would be given by 3 times x squared, or we have 3x cubed plus, out of the second term we just have a 2. So f prime of x is given by 5x e to the x cubed times the quantity 3x cubed plus 2. For our third example, we have y equal to 5 raised to the quantity 2x cubed minus x squared plus 2x minus 4. The form of the function given here is in the form of a to the u. Recall that in differentiating with respect to x an a to the u function, the derivative will just equal a to the u times ln of a times du dx. In our example, a is 5 and u is 2x cubed minus x squared plus 2x minus 4. Hence, differentiating y to give us y prime would result to having the factor 5 raised to 2x cubed minus x squared plus 2x minus 4. This is our a to the u factor. Then we multiply it with ln of the base 5. Then multiplying it further with the derivative of the exponent 2x cubed minus x squared plus 2x minus 4, which is just 6x squared minus 2x plus 2. Now, please take note that among these terms, we have a common factor 2. Hence, we can write y prime equal to 2 times 3x squared minus x plus 1 times 5 raised to 2x cubed minus x squared plus 2x minus 4 times ln of 5. Consider the function f of x equal to the product of 3 raised to x cubed with 7 raised to 3x squared. Here, the function f of x is a product of two factors. Recall how we differentiate a product of f times g. It is equal to the sum of f times the derivative of g with respect to x plus g times the derivative of f with respect to x. Applying that here, f prime of x will now be given by 3 raised to x cubed times the derivative of 7 raised to 3x squared plus the product of 7 to the 3x squared with the derivative of 3 to the x cubed. Differentiating now the exponential function, we make use of the rule derivative with respect to x of a to the u given by a to the u times ln of a times du dx. Applying it here, f prime of x now would be given by the product 3 raised to x cubed times 7 raised to 3x squared times ln of 7 times 6x. Applying this rule, differentiating 7 to the 3x squared. The second term would be product of 7 to the 3x squared times the derivative of 3x cubed, or 3 to the x cubed, which is given by 3 to the x cubed times ln of 3 times 3x squared. F prime of x now can be simplified into this product, noting that among these terms, 3 to the x cubed, 7 to the 3x squared, and 3x would be common factors. Hence, if these are factored out, you have 3 to the x cubed, 7 to the 3x squared, times 3x being the common factor. Out of the first term, we will just have a 2 ln of 7. That's coming from this times ln of 7. And then for the second term, we will just have an x times ln of 3. This is our f prime of x. Or we can write it as 3 to the x cubed plus 1. That is product of 3 to the x cubed times 3 times 7 to the 3x squared times x times the sum 2 ln of 7 plus x ln of 3. Summarizing now on the rules on how to differentiate exponential functions, we have the derivative with respect to x of a to the u is given by a to the u times ln of a times du dx, where u is a function of x. And if we are differentiating an e to the u function with respect to x, its derivative would just be given by e to the u times du dx. Again, u is a function of x.